In lesson 11.7, we're going to be talking about finite differences. The word finite means that there's going to be an end, and differences means that we're going to be subtracting. So we're going to be doing a bunch of subtractions that will eventually end. Okay? So the big idea for this unit is that we're talking about n points. So however many points that we're looking at, n points in a plane. Now a plane that it's talking about is the x, y axis. Okay, so let's say they all fall on the x, y axis. What that's doing for us is that's telling us that it's all in a two-dimensional plane. Okay, this nice little thing here that says no two of the points have the same first coordinate. So they can't all have the same x coordinate. Remember, if we have two of the same x coordinate, we've got 2 points vertically in line, which it wouldn't be a function. Okay, it would fail the vertical line test. So again, we have a specific number of points falling on the xy axis, none of the same first x coordinate. Then it's possible for us to figure out if there is a function of degree less than n minus 1. So like say if we were talking about 5 points, we can figure out if it's degree of less than 4. That would contain all of those points. So what we're going to be trying to do is come up with a function that best represents, is an approximate model to best represent the data points we have. If you were talking about 2 points and only 2 points, 2 points would get you an exact model of a line. Okay, you'd start at one point and ended at the other, and it would be an exact model for that line. But once we add in more than 2 points, then we're looking at an approximate model. So not all of our points will fall directly on the graph we're making, but they're going to fall close, and it's a way for us to predict the future, basically, if we can have an equation. So we're going to be looking for an approximate model of quadratic or exponential models as well as linear to be able to come up with a function. When we say model, we're referring to an actual function that represents the situation. So we look at these data points down here and look at the scatter plot off to the right. It looks like these points, and it's a scatter plot, so we're not connecting them, but it looks like these points are possibly quadratic. But if you recall, this could also be the beginnings of an exponential curve. So right now there's really no way for us to determine which it will be because we only have points within the first quadrant.